So if you are testing only the login page or only the login module, so you will call that as a unit testing. You are testing only one unit for its accuracy. I have three different approaches to develop any software. So what exactly that? Top-down approach, bottom-up approach, Big Bang approach. When it comes to the negative sculpture, the work proceeds by removing the unwanted materials. Hello everyone, I welcome all of you to the next important chapter in the second unit. That's nothing but the levels of testing. My dear students, you would have felt after hearing the levels of testing, yes sir, we have heard about this name very long back. Yes, could you all please recollect where exactly you have heard this name? Yes, I have discussed about this topic in the first chapter. Yes, the same old levels of testing. So I will be discussing about this topic in detail in the second unit. This is one of the important chapter that all of you have. Yes, without wasting much of your time, let me get into the session. So what is that I'm going to discuss in this session? Mainly, I will be focusing on the traditional views of testing levels. Traditional views of testing levels is what I will be discussing. Along with that, I will also discuss alternative life cycle models. So that's what I will be discussing in today's session. So fine, without wasting much of your time and without boring much of you, so let's get into the topic. So guys, I have made a point like, I have something called prerequisites. I've put something called prerequisites. What exactly prerequisites is all about? Yes, before I start this chapter, so you should know some of the basic concepts. So after discussing that basic concepts, let me get into the chapter. What is that prerequisites? What should I know before I get into this chapter? We have something called software development lifecycle, so which we have already discussed in the beginning classes. That's what I will call it as a SDLC. So fine. So you would have heard about a very famous model, software development model, that is Waterfall Model. So please make a note of it. So I will call it as a Waterfall Model. Sir, why it is Waterfall Model? Why the name it is Waterfall? So that's a very interesting story that you need to know. Before that, what exactly this Waterfall Model is all about? So I will call this Waterfall Model as software development model. If I want to develop any software, I have to adopt some of the pattern, some of the model, which I need to follow the path of it. So to develop my software. So in that, one of the famous model is Waterfall Model. So using this model, we develop the softwares. So that's why we call it as a software development model. Now, what is the speciality of Waterfall Model? How exactly water falls? So from this, like this, is it? No. From bottom to up, is it? No. So from top to bottom, it falls. Yes, yes, exactly. So in the same fashion, in the same way, we also develop the software. So how, sir? Let me discuss that. Observe carefully. The first step, what I have, I will be interacting with the clients and I will be collecting all the requirements from the clients. Yes, we all know that. So that is the first step that I have. The next step, what I have, this is an abstract view, in fact. Okay. The next step, what I have, preliminary design. So what exactly preliminary design is all about? So I will be having high level details. Whatever the data that you have collected, so that is not in detail, in depth, you don't have that details. So fine. So if you want the details in depth, so you will go to the next level, that is detailed design. So what happens is, when it comes to the detailed design, so you will have detailed design of each and every unit, each and every module. But when it comes to the preliminary design, you will not have the detailed design, what exactly that you wanted. So then after collecting all the design, so what is the next step that you will go? So you will go for the next one is coding. So this is what you need to observe here. So you are coming one step down, one step down, one step down. So you cannot go back. You cannot go back to the previous step. So that's what you need to understand. That's a major drawback that I have with the waterfall model. And also when you can take up this waterfall model, so when you know the complete model, when you have the complete requirement, so if you know the exact system, what that you need to develop, only then you can start with the waterfall model. If you don't have the proper exact requirement, you cannot use the waterfall model. That's a major drawback that you have. And also, if you start the development of the project, so you have to wait a longer time to get the end product. So all these things is the drawback that I have with the waterfall model. So why do you need for a longer time? Why do you need to wait for a longer time? Because you will have to undergo a lot of steps. You'll have to undergo a lot of steps, and only when you come to the final stage, you will get the final product. So till then, you have to wait how exactly the software looks like. Suppose if there is a bug or if there is any error there, so again, you have to start or you have to do it from the beginning. That's a major problem that you have. One of the important imagination, I want all of you to imagine this. Say for example, the client has come. So client has given some requirement. He has told something and I have understood something and somebody developed something else. So we have taken, to happen this, we have taken, let's imagine 3 months. So after this, I have got one final product which I am showing it to the client. Client finally sees this and they say that, so this is not exactly what I want something else. So if this is the thing, the effort of collecting the requirement and the design team and the development team and the testing team, so all this team has worked, okay, for waste. So this is what you need to remember. This is the drawback of waterfall model. So hope you got the idea of waterfall model before I get into this. And also, in the same way, like this waterfall model, I have other different models, spiral model, increment model, evolutionary model, are different types of models that I have, which I'll be discussing, in the coming sessions, in the coming slides. So, but now keep that in mind. So we are discussing with respect to the waterfall model. Now, how exactly this waterfall model is, correlated to the testing. So we are discussing the levels of testing, how exactly it is correlated with testing. So that's what we are trying to understand in this chapter. So there is a difference between the levels of testing and the types of testing. So please remember that. In this class, I'm discussing the levels of testing. So please remember that. So there is a difference. Yes, let's get into the topic that I have. What exactly that I have? So please observe. Traditional view of testing levels. How exactly we check the testing levels traditionally? Let's check that. When it comes to the traditional view, so the main thing which comes into our mind is unit testing, integration testing, and the system testing. What exactly this unit testing, system testing, and integration testing is all about? How exactly it is correlated with the waterfall model? By now you have got the complete idea about the waterfall model. Yes. Yes, but how exactly these type of testings are correlated with the waterfall model? Let's check this. So we call this as a V model. So guys, I've already spoken about this. This you have seen in the waterfall model. Yes. So now how exactly it is related with the unit testing, integration testing, system testing. Let me explain what is unit testing, what is integration testing, and what is system testing today to all of you. So guys, I've already told you, so here this phase, that is detailed design, is correlated with unit testing. What exactly it means? Unit testing in the sense what? So here in this phase, I will be having the complete idea, detailed design of one particular module. So here, when it comes to the unit testing also, I will be testing the complete module or the one particular unit. So that's what you need to observe. This is how it is correlated. So fine, say for example, I have the software. So I have divided that into multiple different modules. Say for example, let me take a login page. Login is a separate module. So now I have the complete requirement. So here in the detailed design with respect to the login module, I will design and I will develop. Okay. Now I need to test how exactly my login page is working, login module is working. So if you are testing only the login page or only the login module, so you will call that as a unit testing. You are testing only one unit for its accuracy, whether it is working fine or not according to the requirement. So fine, so you understood if you are testing only one unit specifically, that's what we call it as a unit testing. After that, please observe the next one that I have is integration testing. what exactly this integration testing is all about. When it comes to the integration testing, I've already told you about the unit testing. So in a project, I will have a small modules. So I will be testing that individually. If you test like that, I will be calling that as a unit testing. After that, I need to integrate the different modules. Say for example, I'm done with a login page. Now I need to test the home page. After testing both the units, I will integrate. I will join. Then now, before joining, before integrating, it was working fine. After integrating, so is it working fine or not? I need to check. So that is what I will be calling it as a integration testing. After integrating all the modules, okay, after integrating all the modules, you will be checking the entire system. Is it according to the requirement which is given by the client? So that's what I will call it as a system testing. So whenever I'm performing the integration testing, I will be coming across with the two important concepts, that is regression testing. Another one is progression testing, which I will be speaking about in the next slides. Please make a note of it. So regression testing and progression testing, regression and progression. So fine, now you have the clear idea about what is unit testing and what is integration and what is system testing and how it is correlated with the waterfall model. That's what you need to understand here. So hope you got an idea how exactly these testing levels are correlated with the waterfall model. And please understand, it's a very important question that all of you should understand. So what is the question that I have then? What are the three basic methods? What are the three basic methods can be used to develop a system? This is a generalized question. Before we select the models, so we go to this particular question and we discuss the basic methods. What are the three different basic methods that we adopt to develop any softwares? So in that, the first approach that I have is top-down approach. The second approach is bottom-up approach. The third one that I have is Big Bang. So please make a note of this. I have three different approaches to develop any software. So what exactly that? Top-down approach, bottom-up approach, Big Bang approach. So let's understand this one by one in detail now. So guys, when it comes to the top-down approach, or we call it as a top-down integration. So please remember, let me take up this example and let me explain what exactly top-down integration, bottom-up integration, and Big Bang integration. So guys, they are speaking with respect to the testing. That's why I have the word called integration. This is what you need to remember. I need to discuss these topics with respect to the testing. That's why I have the concept of integration. So fine, let me discuss this. Top-down integration in the sense what? What is the meaning of top-down integration? So first I will come to this main module. This is what I will call it as a main module. So here consider this example. So I have the ATM system. So ATM system is a main module. So this ATM system has got the submodule that is terminal input output, manage sessions and conduct transaction. This is the submodules that I have in the first level. So first I will come to the ATM system. So then after that I will come to the terminal input output, manage session and the conduct transaction. Then after that, so I will come to the manage sessions, right? So in that, so I will come to this card entry, so pin entry and select transaction. Observe, I'm using the top-down approach. I am starting from the main module. So this is very, very important. So this is how my top-down integration will happen. So guys, top-down integration would begin with the main program. So main program here is ATM system. Then the checking calls to the next three levels, whatever the procedures that I have. So I will be checking for the next levels, whatever I have. So this way, if you are integrating, okay, first you are taking the main system and then next you are going for the next levels. So this way, if you are going, then I will call that as a top-down integration. Bottom up is entirely opposite to the top down. First you are taking the card entry, pin entry, select transaction, then you are going for the manage sessions. So in this way, if you are going for the integration, so guys, then I will call that as a bottom-up integration. That's what you need to remember here. Bottom-up approach integration units are high level, are replaced by that emulates the procedure call. The meaning is very simple. Let me make it very simple. So guys, bottom-up in the sense, so from here you are going up. What is the meaning from here going up, sir? Basically, you are starting from the small units and then you start composing, okay? So then you are going for the main module. So first you will start with the small units, okay? Then you are integrating all the small units and then finally you are going for the main module. So that approach is what I will call it as a bottom-up approach integration. So, but when it comes to the Big Bang, so please understand, Big Bang is a very beautiful approach that we have. So Big Bang approach simply puts all the units together at once. It'll dump all the units, whatever you have, so at once, but it will start removing whatever is not required. It will start removing whatever is not required gradually. So that is the most important thing that you need to remember with respect to the Big Bang approach. So hope you understood 3 different approaches. So please remember, I'm discussing this concept with respect to the testing. You need to understand, you need to remember this word called integration. So you are trying to integrate. So top down in the sense what? First you have the main program, then you start integrating the subsystems. But bottom up in the sense what? So you have the smaller units, so you will integrate all this and then you will come to the next level. Then you come to the main program. So this integration word is very, very important whenever you're discussing this topic. So fine, so you understood what is the 3 different model or methods that we have to develop the software. So fine, moving forward to the next concept that we have. So guys, what is the next concept that we have? Alternative lifecycle model. What is the next concept that we have? Alternative lifecycle model. Yes, we had a lot of drawbacks in the waterfall model. So we had a lot of issues. So what are the alternate methods that we have? So we were using the decomposition method. Okay, decomposing and composing. That's the 2 words that you need to understand here. That's the 2 technical words which I'm using in this slide. So you need to understand it very carefully. Decomposing and composition. So let me utter these words again. Decomposition and composition. So what is the meaning of decomposition and composition? Decomposition in the sense, so you started splitting the main program into sub programs or small units. So that is decomposing. You're dividing the main program into sub programs, or you're dividing the main program into sub units is what I will call it as a decomposition. Composition is the opposite word to the decomposition. So you start integrating the small units into a main program. That's what I will call it as a composition. Now let's understand this. So guys, in the early days back in the 1980s, practitioners have devised an alternative in response to the shortcomings of traditional waterfall models of software development. So they have found an alternative for this. So they had some of the drawbacks with the waterfall model, as I discussed in the beginning. So that is the point that they need to remember. Common to all this shifts away from functional decomposition to composition. So they wanted to shift from functional decomposition to composition. So they had some problem with the functional decomposition. That's why they are moving into the composition. So that's what you need to remember here. So decomposition is a perfect fit for both top-down and bottom-up testing order. We are discussing with respect to the testing. That's what you need to keep it in mind. Decomposition was a perfect fit for both top-down approach as well as the bottom-up approach. Yes, but when it is perfect, when I know the requirement of that system exactly before I start implementing it, the complete requirement of the system, I should know before. So at that particular time, so decomposition is perfect. But functional decomposition can only be well done when the system is fully understood. That's what they are saying. So I should know the system completely, only then it is perfect for me. If I don't know the complete system, so I cannot depend on the functional decomposition. That's what you need to understand. So that's a very important point that you need to remember. The result is very long separation between the requirement specification and completed system. So yes, complete system is what they say. Very short. Let me conclude, or let me make it very simple for all of you. If I want to develop, or if I want to implement functional decomposition, I should know the complete system before. So that is a major thing. If I don't know, I'm not supposed to use it. That's what they say. So that is the reason that I'm moving to the concept of composition. What is the use of composition? Very interesting. You need to observe the opposite to the point of decomposition. Remember, composition is closer to the way people work. What they know, they start developing that. So gradually they will evolve. Gradually they will increment. Gradually they will add the concepts to the software and they will build. They need not to have the complete idea about what they are doing, what they are developing. So that's a major advantage that the people has got with the composition. Need not to have the complete idea of the system. That's the reason they wanted to move for composition. So this is the idea that you need to remember at this point of time. Moving forward to the next points. A very nice analogy that they say here, that is negative sculpture and the positive sculpture. What exactly is mean? Negative and positive. So let's understand. When it comes to the negative sculpture, the work proceeds by removing the unwanted materials. That's an important thing. So it's kind of a big bang approach. So they will include everything. So once they understand that that is not required to that particular system, they start removing it. So that is the negative sculpture. But when it comes to the positive sculpture, please remember, the mistake part is simply removed and replaced. Only the mistake parts. That's what you need to remember. There is a huge difference between the negative sculpture and the positive sculpture. That's what you need to understand with respect to this. So guys, moving forward to the next topic. Waterfall Spinoff. Waterfall Spinoff. When I come to this topic, mainly I will have three important models. What is that models that I have? As I told you in the beginning prerequisite slide. So guys, I have the waterfall model. So you based on the waterfall model. So it's one of the model which I refer to develop the software. In the same way, I have some of the derivatives of waterfall model, that is increment model, evolutionary model, and spiral model. Yes. What exactly incrementary development model or evolutionary development model or spiral model? So what exactly this is all about? Let's understand these three models quickly. So because this is very interesting. And you need to understand the one common thing in all these models, it builds or it gives you the series of increments or builds. Series in the sense what? What is the meaning of series? Web series. Probably this name would have been very popular in the past days. Web series. So you have episode, different number of episodes, right? So that's what we call it as a series. Okay, N series. Nokia N series. Have you all heard about it? Okay, X series. Okay, in that you will have some different versions. That's what you need to remember. So when I get into this type of models, this provides a series or a builds. That's what I'm going to discuss, yes, in detail in the coming slides. Let's check what exactly I have. So guys, let me start with a life cycle with a build sequence. You need to understand this diagram very carefully. So guys, what exactly life cycle with a build sequence? So please understand. So first one that I have is a requirement specification, which we have already discussed. What exactly is that? So fine. After that, I have a preliminary design. So then I have series builds. What exactly series builds is all about? The end product, whatever I have after the development, after coding. So that's what I will call it as a series build. So why they are using the word called series build? Why are they not using coding? So please understand. So let's imagine I have the coding here. Then after that, the speciality of this is, imagine I'm done with my product. Okay. Say for example, I'm done with my product. I will send it for a testing. I will send it for testing. There is a bug. Okay. Customer is not happy. So what happens? Again, I will go for the detailed design. Again, I will go for the detailed design. So I will correct all my mistakes in the design. So whatever I have the changes, I will do it. Then again, I will go for the series build. So they will implement it, and then again, I will go for a testing. So again, this steps will happen. Okay, again and again, again and again, again and again. That's what you need to understand. When they come to the detailed designing, so obviously coding will happen, unit testing will happen, integration, regression, progression will happen. Sir, yes, you are saying integration testing will happen, regression testing will happen, progression testing will happen. What exactly this test? Yes, we know unit testing, we know integration testing. What is this regression and progression testing? I will be discussing that. Remember this 2 points. What exactly regression testing? What exactly progression testing? Regression testing, in the sense, whatever the points or whatever the unit that I have already developed, okay, I'm just checking whether it is working fine or not, which I've already done. Say for example, I've already developed, okay, so I need to integrate with some new module, okay, so this is the new module, this is the old module. So I need to test this, okay, if it is working fine or not. So after that, I will increment, I will integrate. So this is what I will call it as a regression testing. So it is very, very important for me. So that's what you need to understand. What is this progression testing? After integration, whether it is working fine for me or not. So that is what I will call it as a progression testing. This is what you need to remember as of now. I will be discussing this in detail now, okay, in the coming slides. So fine. So hope you understood what is life cycle with the build sequence. Build sequence in the sense, you will be getting multiple iterations. So fine. This is what you need to remember with this diagram. Let's understand. I have already told you that, I have different models. That is incremental model. So you have already I have discussed about this increment model. You don't have to remember this diagram. Just to give you what exactly incremental model is all about, I have just taken this diagram. Okay. So guys, imagine I have the requirement collection here. Okay. Then I will analyze the design. Then I will implement it. So then after that, testing will happen, evaluation will happen. That's what you need to remember. So this is one increment, one model, one phase. Then after that, yes, I need to change it again. So please understand again, okay, I will build one more sequence. I will build one more module. So again, the same steps will be repeated. That is the next increment. I'm adding some more features to that. Okay, same steps will be repeated. So please remember that. Again, if there is any requirement, it will go for one more build sequence. That's what you need to understand. Iteration. In each and every iteration, you are adding, you are incrementing the different new features is what you need to understand with respect to incremental model. That's what you need to remember. When I come to the evolutionary model, say for example, the diagram speaks very well than me. So I have the version 1, okay, here I have the version 1. So when I move to the next stage, I will release the version 2. I will release the version 2. Again, here also, I'm adding some of the features which was not there in the version 1. Same way, it will start evolving with different versions, okay, with different phases. That's what you need to understand. In the same way, I have the spiral model. In the first iteration, in the first spiral, I had some of those features. In the second spiral, I started adding some more features. So please understand, it is getting divided into 4 parts here. Whenever I'm having a spiral model, it's very, very useful for the risk analysis. That's what you need to understand. Okay. So all these models are derived from the waterfall model, and each model, whatever you are seeing here, are releasing different build sequences or a build series. So every time you get a different builds. So it is not only one build and you got it and you go. No, it is not like that. Say for example, I'm done with one phase and I'll give it to the customer. Customer will say that it's not okay, do some changes. Again, I'll go for one more iteration. So this is, I will do the second iteration. I will do it something. I will correct whatever the customer says, and then I will repeat the same steps, and then I'll give you the final product again. So customer will give me the feedback about it. So if he is happy, I'm done. Otherwise, I should go for one more iteration. So this is what I will call it as a build sequences or build series. But when it comes to the waterfall model, it is not like that. So that's what you need to remember. That's the major drawback that I have. Waterfall model is one complete step. There is no iteration. There is no iteration. One step done. Kaam khatam kel band. So that's what you need to remember. So guys, so that's what I have listed out some of the drawbacks which I have with respect to the waterfall model. All right, so it's too slow. It takes it takes a lot of time now to know the end product. If you want to know how exactly the end product looks like, it takes a lot of time. It's too rigid, so there is no flexibility to change the requirement. No going back to the previous step. If you are in the requirement step or if you are in the design phase, you cannot go back to the previous steps. So that's what you need to remember. So, and 2 focuses on the top-down functional development, bottom-up testing. That's what you need to remember. And not the way the people work. So it's not so flexible is what they are trying to say. Staffing levels are different types, batched at different times with the levels require large resource shift from low to high and back. That's a very tedious task that we have with a waterfall model. That's a lot of different drawbacks as we discussed in the beginning. So that's why we prefer the models which I discussed in the previous session. So guys, this is what you need to understand here. All right. So as I told you, the system testing is getting divided into 2 parts. One is regression and progression. I think I've already discussed about what is regression and what is progression. Let me just give you the quick recap of regression and progression. The aim of regression is to confirm that the thing worked correctly in the earlier build still work with the newly added code. What is the meaning? So whatever I have built already, so that's what I will call it as the old. So it is working fine even after the new code is there. So that's what you need to remember. So correctly, so please understand, worked correctly in the early build. So still work with the newly added code. It is still working with the newly added code. So that's what you need to understand. That's what we call it as a regression. What is the meaning of progression? Please understand. Progression testing assumes that regression testing was successful. This is successful and that new functionality can be tested. What is the meaning of it? So this is working fine. So imagine here, this is an integration. All right. So this is what I have, old one. So this is working fine. Assuming that this is working fine, I will test only the new one. So this part is what I will call it as a progression. So that's what you need to understand. So keep it simple. So testing the old one is a regression and testing the new one is progression. That's what you need to remember to keep it very simple. So guys, this is what you need to remember with respect to the waterfall spin-off. All right. So I have some more points with respect to the waterfall spin-off. Let me just give you a glance through that. So guys, regression testing is necessary. So please remember, this is very, very important point. Regression testing is necessary in a sequence of builds. In a sequence of builds. Sequence of builds in the sense what? Number of iterations you have taken and different builds you have. At that particular point of time, regression testing is very important. That's what you need to remember. So fine, the incremental development. In the incremental development, the motivation of separate builds is usually to level of the staff people. That's what you need to understand. So whenever you are developing incrementally, so please understand, motivation for separate builds. Motivation for separate builds is usually to the level of the staff of people. So you are dividing basically you are dividing the set of main program into different increment builds. You're not building together. So that's what you need to remember. A spiral model is a combination of rapid prototyping and evolutionary development. This is one of the important things. So you all know what is evolutionary, version to version. But what is this rapid prototyping? What is this rapid? What is this prototyping? So let's understand. Rapid in the sense you all know that it is very quick and fast. What is prototyping? Prototyping in the sense you are developing, you are making a similar model, but it's not exactly the software. Okay, so that's what we call it as a prototyping. So why are you not building the exact software? If there is any error in that, if I develop an exact software, it's a waste of time for me, waste of effort for me. So that's why I'm not building the software. Instead of that, I'm building a prototype. Quick model of that particular software is what I will call as a rapid prototyping. So how exactly then I'm doing the rapid prototyping? Yes, I will be discussing that in my next session. So guys, before that, let me discuss some of the drawbacks again of waterfall model, which I've already discussed. So guys, keeping the preliminary design as an integral part or integral step is difficult for the evolutionary and spiral model. So that's very, very difficult. So So what is the meaning of it? Preliminary design in the sense high level design. So you don't have the detailed design. So that is very difficult. So for the evolutionary and spiral model. So that's what you need to remember. And to extend integral activity. So integral activity in the sense, so what is the meaning of it? So please understand, extend to an extent integral activity in the sense you have the activity, a part of the activity is negatively affected in the integration testing. So that's what you need to understand. So that's what you need to understand. If you have the preliminary design as a integral activity, definitely it will affect the integration testing. That's what you need to remember. Let me tell you this one more time. I have the integration testing. Alright, so I have the integration testing. Yes, I have the preliminary design. I have the preliminary design. You are considering the preliminary design as a part of the system. If you consider that as a part of the system, my dear students, that is going to be a problem for the integration testing is what they are saying. Alright, so that's what you need to understand. By this, I have come to an end of this session. So if you want to know more on this chapter, so please don't forget to watch the next session. So till then, take care. Bye-bye.